array. Chaos is here today. Motors hum and systems shake. Reliability's what we make. Motor Dock leads. Reliability squash meets the needs. On Veterans Day we stand as one, keeping industry running strong.
Well, hello and welcome to Chaos and Caffeine, episode 18. I'm a little under the weather still. I just got back from Denver, from the Grid of the Future conference, which went very well. We'll talk about that in just a little bit. This week, because I don't have my full taste back, I don't want to be unfair to the things I'm tasting, but there was an instant coffee that I used to enjoy whenever I'd go over to South Korea. This one is the Maxim one. There's a number of other ones. I used to order them once in a while because they have pre-mixed sugar and creamer in them, but they're quite good. So I'm going to go ahead and get this out of the way, and then we'll get into what this post is really about, which is I was going to do it last week, but I didn't really get a chance to. This will be a Veterans Day post, just post-Veterans Day. Not too bad. Although I don't take sugar and creamer in my coffee, that came out pretty good. I've had these around for a little bit. They're still in date, so gave it a shot. If you ever want to try it, they're pretty good on the go. If you do, definitely a light colored coffee. If you ever do it, you can get them right off of Amazon. This one again is at Maxim, and then they've got other ones like it. Just look up Korean instant coffee, and you'll get it. Used to go over there all the time. That was what was in all the offices because a lot of people drink tea as well, especially in Asia. So one of the things that was really kind of neat last week was I had been sent a set of boxes from where I used to live and opened them up, and I found a few things like this one, how to become an electrician's mate. This one here is all of my notes from Electrician's Mate A School from 1985. So I will go through some of this randomly. I haven't gone through it yet. There's even an old picture of me doing a leg press, but this is after I got out. So this would have been circa 1990, because this is when I lived in Gloucester, Virginia. That would be about roughly 1,000 pounds for, I used to do it for 100 reps. Sets of 10. So, and then this is the biggie. This one here, I got when I went to my C school, the Rewind C school. This would have been 1987. So I was an EM2 at that point. So this is the Electric Motor Rewind course, and it was one of the last ones done at the Fleet Training Center in Norfolk, Virginia. So we had a whole rewind shop there that we were taught in. This is all of the notes. I'm going to randomly go through some of this, including some of the testing. But this is the basis for everything I do now. The electrician's mate part, that's basically classes to be an industrial electrician. So we'll go through each of these a little bit. First, I want to just cover a little bit on last week. So, as you hear me talk a lot about wind and any other energy source, the clean, what we're calling clean energy sources at this point. But in engineering now, we call all of the utility scale stuff, the big ones you see off the highway, those we're calling inverter-based resources, or IBRs. Now, that was meant to present a problem instead of a solution with the engineering community, because they were trying to say that certain things were going on that were coming from the wind and solar and energy storage industry back into the grid. And my part of my thing is just challenging that. For those who've known me for a while, you know that I'm about challenging recent assumptions. That even came up several times in the conference. Now, one of the things that we did as MotorDoc was we funded so that the panels from that conference, the Seagray Grid of the Future, this is going to go on. I'm at the end of it. I was able to sleep for the first time last night. Luckily, my talk was on the first day of the conference, and I was able to do that before I got unwell. Just say a lot of people flying and a lot of crowding because of all of the shutdown stuff. And of course, it's that time of year where everybody's sick, so everybody's hacking and coughing. So, it's bound to happen once in a while. Okay, so I digress. So part of my whole thing has been to challenge assumptions. So, like, for instance, there were several points brought up about the Iberian Peninsula blackout, even, obvious biased positions on the reports, including the recent factual report from ENSO-E. Well, I've read all these as well, so my position was to bias it kind of the other direction, so that we can find something in the middle. I do that on the IEEE Grid Code Committee and everything else, because there's things that you have to challenge. Now, I've been involved in all of this since the early 1990s, so well over 30 years. 32 years now. So when I look at this stuff, I look at it from the standpoint of, making sure we challenge it, not to be a dick about it, I guess, but more or less to get people thinking out of the box, because everybody is locked in on the way things have been, but the grid has changed. The discussion was even, and a majority of the discussion actually moved away from IBRs and more towards data centers this time. A big part of the discussion had to do with the fact that the grid had been relatively stable right up until about a decade ago, and then it's been increasing, and right now it's increasing at an astronomical pace, and with the application of data centers. Then to top it off, there's a lot of these, data centers that start building out infrastructure and start working on all this stuff, and then they don't happen. That's happening in a lot of areas where investors are involved. They'll start investing, and then all of a sudden everybody will pull out, or it was never going to happen in the first place, and the idea was just to get investment money flowing and then kill the project. So we've seen that in clean energy, not a lot of it, because there's certain regulatory requirements, but we definitely see that in the data center world, which is the Wild West. Absolute Wild West. So we did even have one of the senior folks from AWS there to talk about, and his job is the energy side. Now, when I'm talking about these folks on the panels, I'm not talking about, some guy within the organization. I'm talking about, we had the VPs on the technical parts, we had CEOs of corporations, we had leadership that, you would recognize the names. If you're on the technical side, going back a long time. So we funded the part where the panels, not my talk, for instance, I wasn't on a panel, but we funded so that these panels with these people will be published within the Seagray environment. I'm waiting to see if we're going to be allowed to share those publicly. I'm hoping we can, because there was some really good information. Some of it included, again, going back to the IBRs, a lot of the standards and stuff that are being developed around IBRs, because for some reason the clean energy community is not getting involved in the electrical standards. They're heavily involved in the mechanical standards and the structural standards, but have left out the electrical standards to the point where they're being dictated to on how they're supposed to run because there's hardly anybody, if anybody, on the standards groups. So neither here nor there. So let's get into A school. Now, A school means that what happened is you get out of boot camp, and then I went to the first school, because to go into A school, you have to get the basics of electricity. So to go into be an electronics specialist or an electrician's mate or an IC-man, you have to go through something called BEE, or basic electricity and electronics, in which we learn to solder and weld, basic weld, do all the stuff, troubleshoot circuits, how to troubleshoot circuits, like take a big circuit, divide it in half, figure out from that half, and then divide it and divide it and divide it until you hit the problem. And that's the way I've always troubleshot ever after. It's definitely very, it involves a lot of critical thinking. And the idea is the methodology they taught us was supposed to be able to be applied in battle conditions. So when you think about it, it's fast. And people go, how the heck did you walk in there and get things done so fast? Well, it's because I had training. Everything I do now, this is the basis. So let's open it up. Night study. Oh, yeah, that's right. I had to do some night study. Oh, this is on the 3M system. That would have been out of the ship. Basic refrigeration cycles. People go, well, how do you know all this stuff? Well, because I went through it. All the protective devices. So these are outlines. Degaussing. How ships induce magnetic fields work. So people go, how do you know so much about grounding system? Electricians, mate, in the Navy. We had to know certain things about how magnetic fields worked, or we got sunk. All the capabilities back in that time when everything was still pretty analog. Oh, signal converters, OR, NOR, AND gates. All of the stuff, all of the analog and digital circuits, we had to learn that stuff. So let's get back into a little more detail. That's what we had to do for each thing that we were allowed to do in the military. This is another thing, because I've run around in this. I'll go into a shop and they say, well, he's a level 1 tech or he's a level 2 tech. Well, how do you know? Well, he has to do this or that to do it. Is it something that's standardized across the? No, it tends to be, local. Which is fine. In the Navy, or in the military, the Navy, I'm just going to call it the Navy. This is probably standardized across the other services too, but it was called Personal Qualification Standards, or PQS. So whenever we went through anything, we had to work on. I did go to a C school called the 8mm projector school. Learned how to splice 8mm stuff. Like if you watch the old World War II movies and you see the big reels and that's how they watch movies, yep, I got to learn how to edit that stuff back then. So in order to be finished, I did the school and everything else. Then I had to go around and demonstrate my ability to do the work. And then somebody who was already qualified in it, depending on what the job was. So, for instance, in Rewind, as I was working on my Rewind journeymanship, I had to have another Rewind journeyman of chief for hire check off that I knew each component. So I was the youngest journeyman, because you're usually supposed to be you have to sign up for 6 years to go after it. I just did 4. So in any case, PQS, very, very important. So in order to have each qualification, there was a checklist. Training, followed by, and that could be self-paced with books and manuals. We even did this on advancing to the next rate. So if you were going to go from an EM3 to an EM2 to an EM1, you had to go through PQS to demonstrate that you knew the duties of that next level above. Now, this was not PQS for the level you're in. This is, you're in this level. If you want to advance, you had to demonstrate that you could do the work in that next part of your career before you could be moved into that career. Then, of course, there's a test and everything else that goes with that as well. So learn, demonstrate, test. It could be learn, test, demonstrate, either way, but you were not qualified to something until you could show those qualifications. I didn't bring it in, but I have a stack like this sitting back at home. Every watch I stood, everything else, all checked off in books. That's kept with your record. It used to be paper, and they sent me my paper records. Safety, that's a big section. First aid and CPR. Back in the days when you used to do mouth to mouth. Yeah, we had Annie as well. And then the 3M system, all kinds of stuff. Wow. And now, just so you know, I'm just opening this for the first time since I got it. Papers are actually in relatively good shape. Little yellow, definitely a little bit of coffee stain here and there. Though definitely will be in the Rewind one. Yep, so all the graphic symbols, somebody said, how do you know how to read all these single lines? Well, because I had to learn. That was part of it. We had to know how to do all this stuff. You, as an electrician's mate, you had to basically be an engineer. People who went on to nuke school and stuff, they got the equivalent of a 4-year degree in about 2 years. Give them a lot of respect. I definitely avoided going to nuke school. Distribution systems, how they're made up, all the different levels, and guess what? It's almost the same thing as civilian, except we had a 4-wire ungrounded system on ship. Dog and Pony Show, where we had to demonstrate stuff. Week 3, my worst one, AC generators. So yeah, I had to do that class twice, which is part of the reason I wanted the Rewind shop when I got out there. But all the stuff I talk about now, here it all is. I mean, it's funny. Physics doesn't change. Stuff I'm writing about now, this was in the books that I was training from back then. EMF, KVA, kilowatts, kVAR, theory and application stuff. Electromagnetics, that led right into the next week. I think there was motors class. DC generators came after that. How to deal with DC. I do a lot of DC work to this day. I know I'm not showing this stuff up there. Motors, of course. DC motors. They went with that old thing that everybody used to do. Wound rotor motors. Well, that definitely helped me with the wind industry. They did what a lot of people used to do in that time, and they would do DC motors and armatures and show the interaction between the armature fields and the stator fields. And then you would learn AC. And you would use the principles from DC going into AC. And I remember in 2007 getting in some weird argument with some folks that were, but they weren't taught DC at all, obviously. So they were trying to argue things from a different perspective. I was right, but that's neither here nor there. So anyways, continued on how to do actually the basics of how the winding occurs. So in order to do motor work, you had to understand the connections and what they're doing inside the motor. We don't teach that stuff these days. We do not teach the underlying principles. And that's what, as I'm going through this, I'm realizing, I haven't looked at this yet. You're watching me going through this for the first time since the 1980s. And I'm realizing that a lot of the stuff that I'm writing about now and that I'm talking about now and that I'm working on now, all of that basics comes from this. Has nothing to do with what I got in college or university. That was basically some book stuff and didn't connect. Just kind of Yeah. One day I'm learning about signal processing, and the next quarter, the same course, I'm learning about something else, and it doesn't relate. That kind of thing. So, no, we had to learn the works. So if I'm looking at let's see if a motor circuit, how it works, and all the lighting and everything else. I don't see anything this simple these days. They all trying to make it complicated. Well, we got to learn the simple side. We got to learn the basics. Week 6, huh? Well, even electricians had to learn the basic seam cycle. So that was all of that week was learning how steam worked, because we had to understand how the generator stuff. So we had to understand the entire system, how it all worked together, which made us more effective in everything we did. Watch lists. Yeah, so, well, one of the big things we had to worry about was isolating for grounds because of the fact that we were an ungrounded system. So learned a lot about ground, actually learned a fair amount about harmonics too. I didn't understand what I was learning at the time until I got in the field. Sound-powered phones, that's for the IC side. So all of this we had to learn. Okay, we're getting into the stuff that I can't show at all or can't even talk about. Okay, there we go. Just kidding. I wrote a big confidential across it because these were the old basic radiological control stuff. There's nothing confidential about it, really. It's in the published books that are public domain. So my old Electricians made books are down there, and all that stuff's in there. Then we get into, here we go. I'm on board ship. So, yeah. Aft steering watch, training I got from Electricians mate Chief Melchert, one of my good friends. Went over to his house a few times. Remember him quite well. He retired and went back up to northern Wisconsin. All the stuff about how aft steering works and lockout, tagout stuff. This is what we used. Now, one of the differences we had in the military was we were allowed to tag out, meaning that you could hang something on the switch and say, do not energize without a lock on it. That's why, actually, one of the reasons we still call on the civilian side lockout, tagout. And the reason had to do with if we were in battle conditions and something had to be energized, you energized it. And, if you had to save the ship and sacrifice somebody, so be it. But that's not really what happens, but that's how it was put to us in the day. Oh my gosh, look at that. Intro to electric motors. Yep, all of this. This is my first little write-up on how an electric motor works. The rest of it. So that is... Yep. Oh, what's this? I forgot about this. So this is when I started doing... Oh, gosh. Old girlfriend. And friends. But anyways, and I being my old sense of humor, I called each of my note-taking things NAB bullshit. 1, this is 2, E2 division. Oh, this is old. This was A school as well. The hell was Michelle? So anyhow, so go in and this is more of my first year. This is when I was still a fireman. So I was just into A school here as well. So this is other stuff, color codes of wires, and wow. Really, really cool stuff. So, that's that. So that is, we learned how to do basic troubleshooting. We learned oscilloscopes, and we learned all the tools, all the stuff I wish an electrical engineer would know. But we don't seem to think that they need to know the basics. So let's put them in charge of important stuff, because I sure wouldn't want somebody who didn't understand the basics running an aircraft carrier like we did. I mean, I was lucky I had 100 people to go to. If I forgot something, I didn't understand something, I had other people. But you get into smaller vessels, they didn't have that. So you would be completely independent. We had to figure things out for ourselves an awful lot. So, get out to the Navy. First thing I asked for on the Theodore Roosevelt, as one of the first 100 on board ship, they said, actually it was Chief Melcher, said, what do you want to do? And get this, Senior Chief Short. Yep, Electricians mate, Senior Chief Short. And from what I understand from some of the veteran stuff I'm on from those days, there's a few chats that we have that stay in touch with shipmates. He passed away a couple of years ago. Senior Chief Short. I think he made Master Chief later. But in any case, let's take a look at this. This is going to get into some detail. Now, this is an addition. We had to learn the naval rewind books, which I was involved in the editing around that time, and actually ended up working for one of the companies that was involved in one of the methods that we were looking into. Now, why was I involved? Well, we were being built, and I had certain qualifications. I took this after we were deployed. We were still doing shakedown cruises after we were commissioned. So I had to do this just as I got my journeymanship, which was at the age of 20 or 21. In any case, safety notifications, here's the class schedule. It's 8-week course, it looks like, if I remember right, each week when we did labs, when we did this and that, written exams. Wow. They go into detail. More training programs should be written like that, right? So you get the whole thing. So let's, first part is chain of command stuff. Of course, I didn't write anything down. We were probably given handouts. Let's see if I have any of those in here. Nope. So, all the stuff that's required. That's all the military stuff, UCMJ stuff. Now, we had to learn some mechanical stuff. Notice the gauges. So this is, I was already on board ship. I worked on lathes and everything else. So when people talk to me and they go, oh, what do you know about machining? Well, I learned on the go. I think I even took some PQS. So I actually have to go look. I might actually have military qualifications for machining. But this one, bore gauges, shaft diameter, and dial indicators, we were the ones who had to make the initial measurements when we tore down a motor on what the fits were of the bearings and everything else. So everything had to be measured. I took this on to, when I worked at Drysilver, I took this on there. They were doing it already. Later on, when we worked on ISO 9000, I applied a lot of this. So, the NAVC 0900 LP 060 210. So that is the Navy Rewind Manual. Then even going through how to make sure we met the bearing sizes, how to take measurements at different levels and in 3 positions, all the stuff I do now, or did when I was a mechanic, and when I was briefly machining. So, I did all this after I got out too. I got out and wanted to be a winder at a repair shop. It was funny because of all this training. The winding supervisor looked at me and said, "I'm going to tell the owners that you don't know anything about winding." And I go, "I just described every connection you threw at me." He goes, "Yeah, I need a book, and if they hire you, you'll be my boss." Later on, I was his boss. So in any case, so let's take a look. And then we get into the Megger. And Megometer, this is an example of one that we used. It's analog, of course. We also use the crank type. They describe a particular manufacturer, and, oh my gosh, they describe a manufacturer. Well, yes, because we used specific manufacturers. We had contracts with them. So this was a General Radio type 1863 Megger. It was electrical, meaning you plugged it in. They should also cover the crank Meggers. It discusses all the dangers of applying it and everything else. How to set it up, measurement setup. So basically, the user manual, more or less. So you set it at the lowest range, set it discharge, connect ground terminal, da-da-da. And then you go through. Now, does it tell me what my limits are? No, not there. Then we used the Baker 5000, which was an analog surge tester. That's what I was trained on. And then we had, we did have a Baker 5000 onboard ship at the time. So that was my tester. So I learned that first. And we go through, and it just talks about how to use it first. Then this table, which is or was in the old NFPA 70B. This is the table for how to look at the waveforms. That is based upon one of the founders of Baker, who I knew at the time. He died, I think, in the late to mid 1990s in an aircraft accident in Colorado. Then digital low ohm readings. The Valhalla. If you think I'm kidding, there you go. The Valhalla. This was our low ohm meter. So I'm going through this going, okay, these were the instructions. And then it talks about how to look at phase balance stuff and everything else. So believe it or not, there's no difference between this stuff here and what we have in standards now. Then, of course, dielectric test set, high pot testing. One of the things we talked about, we get the instructions. So that was how to use the testing technology, how to disassemble a motor. So preliminary preparation, end bell removal, conduct electrical and mechanical tests, preparation before reassembly, pre-assembly tests, motor assembly tests, etc. All of them are here in detail. Let's see if we have some of the test results here. The ground reading is low. Clean the winding in accordance with NAV C 0900 LP 060 210. I still have a copy of that too. I have the later copy. Use a strobe attack to measure speed when you do a test run. Dip and bake procedures. And believe it or not, these are the procedures I took with me when I wrote when I helped write the ISO 9002. Effects of varnishing new windings. Seals the windings from oil, dirt, and moisture. Binds the winding into a solid mass. Provides a film over the winding. Those are the benefits of varnishing the winding. You don't hear me say anything about it doing anything with insulation because technically it's just there as glue. The conductors of the machine are your insulator. So it goes through how to prepare a new winding, measure winding resistance, insulation resistance, check the lead marking, check winding with a surge tester, check for reverse coil or phase, use a little spinny thing. Sometimes, because they didn't supply us with everything right away, I came up with a method that I learned from somebody else where we would put a Coke can on a stick and stick it in there and have it spin. And then later I learned you could do the same thing. You energize the motor at 10%, and then you spin a bearing in there, and it'll just watch it zoom around. If it hits a spot where you've got a reverse coil, it'll shoot out the end. Ensure that phase insulation extends beyond the turns. Make sure, so there's a quality control check that we had to go through. Connections are electrically sound and neat. Wedges are properly positioned and neat. Phase insulation extends to meet the slot cell. Slot cells extend uniformly 3/8 inch past the core, and that they are cuffed. The reason for cuffing is to create a gentler change from a stiff steel portion to the loose winding part. If you don't do that, over time it'll wear away the insulation system and go to ground. Slot cell material is not torn or damaged. Windings are not damaged. Any sloppy appearance, so poor workmanship, was considered sloppy appearance. And correct any winding faults before the varnishing. And it goes through step by step how you do the dip process. Then we get into varnishing, and they take it right out of the NAVC section. So that's copy out of NAVC. Goes through all that stuff. How to varnish reconditioned windings. Let's see. I want to see if I can see some using how to check viscosity of the varnish. Because we didn't send it out. We had to do it on our own. Had to learn how to thin varnish. I had to use that later when repair shop I went to had a problem with getting the varnish under control, and I worked with chemists from the vibration place. The insulation place. Even how to use a Daimler cup and take a look at the viscosity so that we could use that. Then all about the winding, what temperature to immerse it in the varnish. Now, this was based on the varnish we were using. DC motor section. So basically going through again more in depth how it works, how the connections work, how the strength of the field works, how the strength of the armature field works, how to troubleshoot DC field motors. And that included the drop test and everything else, all of which we have in standards. No different than what's in here, obviously. Rewinding DC motor fields. Literally, for those of you in the motor industry, instead of counting, how to compute the number of turns in a winding. So what we would do, and what I did at the motor shop on board ship, because we had some DC actuators and stuff like that we would work on, not little guys but big guys. We do the average length of the coil, weight, size of the wire, and everything else. Come up with a calculation. We'd have that as our estimate, and then we'd count manually, and that would give us an idea of where we were. So we ran that exercise a few times there, how to make the field coils, and then here's all the charts, from wire charts to formula sheets, for actually the same thing that's in the let's see, I don't have one readily available, the little ESA pocket books. Exact same thing, no different. And then doing neutral on a DC motor, we had to do that even then. When I got out and I was doing field work, I knew all this stuff already because I'd been doing it. Yeah, we had DC motors on an aircraft carrier. Okay, so going into armature winding, all the different connection types, I did quite a few of those. Sometimes the guys bring some of their home stuff in. Heck, we even did drills at one point because they were hard to get a hold of and couldn't just go out and get whatever. Identifying troubleshooting DC windings, which was how to determine the winding type through measurements. And this had to do with, we had some special testers that I got to use later. And then how to use also with just a milliamp meter and a low voltage supply. Yeah, all the different stuff. Walking through what it should look like. Bar-to-bar tests. armature testing charts for simplex single lap, duplex double lap, simplex single wave, duplex single wave, or duplex double wave. Yeah. How to use the growler test, even learn the history. And of course, all the armature stuff. Past that. So connection diagrams and how to do it. So this is all very, very detailed. These were all the things we had to do in labs as well. Single phase motor winding, which I did some of that. Ran a small repair shop in Virginia for a couple of years and did a lot of small AC farm motors and a lot single phase farm motors and a lot of the other stuff. Looking for here is to see where our tolerances are. We did cover the tolerances, but I think those were in. I think we had to refer to the standards for that, because like for instance, our Megger test pass fail was 1 megohm, corrected for temperature. Corrected for temperature, folks. One of the things I'm thinking about doing on a technical end of it, here we go. Assembly of a 3-phase motor. So we didn't learn in A school, we learned here. How they're positioned, how they're laid. You had to understand the basics in order to understand how a winding works. How to convert windings from consequent to lap. Things like that. Because the lap was far easier and we preferred it, seeing as we were winding it, so we'd convert them over. Wow. This is interesting. It's basically all the stuff I talk about now. I'm trying to simulate this stuff now, and I can't get the simulation softwares that are supposed to do it right, which explains why I've been able to do some things that some of the manufacturers say are impossible. Different winding designs, how they're all connected and everything else. And then let's see if they have something here. What's this? LS. Oh. Huh. Oh. That was when I came home and I was building my first computer. That would have been 1988. I ordered this stuff, so it'd be there in 1989. Yep, all the details on how to configure, how to find connections if you don't know, how to identify shorts without a surge tester, connect winding to low voltage DC supply, connect potential between each line lead and the Y connection point, and then look for them to be balanced. Wow. Here's all this is what we called quals. We had our own different things, but it says like stand clear, energize the armature, so yep, did that type thing. We would have had a different, whoever was checking us out would have had that date and initials. Okay, and then, these are all the tests. Okay, how to demonstrate that we knew what we did. So we didn't keep that with this, but that was it. And what's this back here? This is reading assignments. Electric motor repair, Rosenberg. This one is right here. Rosenberg in hand. Tells us which chapter to go to and everything else. Old friend of mine, actually girlfriend of mine, bought that for me while I was in. And let's see. Continuity phase method. Appendix. This has to do with continuity winding. How to do a continuous winding. This was important as heck. This was the part, and this is how we do it now in repair shops. So you got one big winding machine, and then you do it so that you would have one complete phase, all the jumpers are already done. And then you mix them the correct way, and then you lay them in the coils. Yeah, and there you go. Step by step. All the jumpers and everything else. So, of course, we didn't have nice color, cute pictures, military and all. We had crappy printers. But these are supposed to be examples of how to line them up to be laid one at a time into the stator. And you would start with the first slot, you'd work your way around and just be able to take them right off here one at a time. And that's what we did in the rewind shop. Then examples of cutting coil ends, and wow. Yeah, all this stuff. Supposedly pictures. I mean, they look better in the overheads they showed. Rewinding machines with random windings, form coil windings, magnet wire types. Yeah, so that is about it. So, wow. I mean, yeah, the images were a little bit better way back when. Here we go. And even to the extent of proper placement of wedges. This is all for random wound, and that part had some form wound stuff we did as well. So a lot of very nostalgic stuff, but hope you enjoyed that. That, folks, is how I learned initially, and now I get people, oh yeah, just tell me how to do this in a day or two. Well, I'm still learning, folks, and I said I'd retire when I know everything there is to know about electric motors, which means I'm going to retire when I'm about 200 or so. But in any case, this had given me an interesting idea. Going back and seeing this just now, one of the things I think I'm going to do through 2026, because I've noticed some horrible stuff in the field. Oh my God, and then the stuff that's coming off of AI right now, sorry, stuff that's coming off of AI right now related to all this stuff is so horribly wrong. I just saw yet another one today. Somebody posted on LinkedIn to try to show how much they knew, and I'm going, oh my God, and people are reading this stuff. So here's what I am looking at doing next year. In addition to the stuff we do related to electrical and current signature analysis, some of the other stuff, we are going to do a series. I did a Back to Basics a long time ago, 2000s, and I included in the Blue Book in 2008. We are going to go back. We're going to cover standards related to motor testing. We're going to cover some theory, how they work. We are going to cover a lot of stuff from the very basics about electric machines and how they're applied and why they're applied and how you test them and why those conditions occur. And we're going to try, or I'm going to try, to do it from the perspective of simple, meaning that the basics, so that those of you who do want to follow this stuff can understand a bit more about how they work, why do certain things occur, how do they occur. I mean, people call us all the time, and I go in, and because of this background and the fact that I continued on this background when I got into the civilian side and focused on the basics that I had learned, I had my intern this last summer. We went out in the field, and it was like, well, why is that occurring? Well, there's only a couple of things that can cause that. And I walk up to the guy, this water department, and I said, the controls guy, I said, hey, can you check and make sure the valve is all the way closed? Well, the thing says it's all the way closed. Yeah, but can you check? Because the only way that motor is going to do that is if it's got a load on it or the windings failed. And all the data I'm seeing is that it's probably going to be the other. So we went in and made the adjustment. In the meantime, we went over and did some other testing. Didn't tell anybody what was going on. So we walked back over again. It's like, okay, let's see what happens when it starts up. Start up beautifully. They had a motor shop and a pump company and the customer and everybody else pointing fingers at each other. And in the end, what it turned out to be was a simple adjustment of a limit switch. Yep, you heard that, folks. So we often find that's the case. Everybody's looking for some big grand thing. And in other cases, like one we were just on, it can be a combination of things. Like, the one we just dealt with on a pipeline, they had a foaming issue because they were, AI, yay AI. It suggested that they go to a hydraulic fluid, which was half the cost of a turbine oil, and it looked the same, but they are actually very different. So they had foaming issues, but then we also discovered, we took the bearing apart to the idea the seal was leaking. So we went in to repair the seal and found out that they had properly sealed the top part of the outer seal, the labyrinth seal, but on the bottom, all the bolts didn't have anything to seal it, so oil was just pouring out past them as the oil foamed up inside the bearing. It's like, go AI, go basics. And then even the OEM had not put enough sealant on certain things. You could see where they put dabs of it on there because it must have said put sealant on the surface, and that's all they did. They put some in a couple of spots. So that was all taken care of. If you're following some of the stuff we do on LinkedIn, you'll see some of it. But knowing the basics, going out and what's happening is people don't understand the basics. We see that from the wireless vibration companies out there that they want to sell vibration sensors and their latest AI software developed by the same companies that are developing everybody's AI software, not ours, but everybody else's. And not understanding what they're doing. So you'll see sensors placed everywhere but where they need to be placed. We work with some of the companies now that we're seeing where they're placing them correctly because they've been around for a while. They want to be around for a while longer, not just sell sensors. We're seeing that in other places too. I mean, part of the reason I'm in the industry I'm in now was because when I was at the University of Illinois at Chicago, and I called two motor circuit analysis companies, and I said, hey, this is great. I'm seeing this. What does the data mean? And both companies basically said, we'll just provide the data. One gave me an answer that was absolutely wrong, and the other one said, well, you have to figure it out yourself. So I went to work for one of the companies so I could do data interpretation stuff, and here I am. Brought one of the systems I use now, or we distribute now, called the Empath, and brought that to that company. But I understood the underlying basics. Then being able to apply what we were seeing to those underlying basics allowed us to identify the conditions that were going on. My bias is back to basics. So, and also understanding that we might see not just one problem, but there might be multiple issues going on in a system, right? I always refer to an electric motor as a very expensive fuse. And with that, happy Veteran Day to my fellow veterans. And to answer the question, because I've seen some of this on LinkedIn, and I checked about some of the folks and that whole false valor thing, or whatever the hell they call it, I don't care. Yes, there is a difference between veterans. Yes, there are combat veterans. They have run into a lot of interesting things. There are regular veterans. I am a regular veteran. I left the Navy. I was in the Cold War, which meant that we were constantly on alert. But I left right before all of the action in 1989 and 1990. My brother, on the other hand, is a combat veteran. So there is a slight difference there, right? And you can tell from the medals. I have very few. I spent most of my time worrying about technology and being a nerd. My brother worried more about running around behind the lines type thing. Yeah, there is a difference there. But we're all veterans. We all served. I think all of the service industry on that side, military, we'll include the Coast Guard in that, and first responders make up about 1% of our community. So with that, respect, folks, and we'll see you on the other side.